In this video, I'm going to be showing you how to hand forge your own leather punches. Hi, I'm Dennis Frechette and welcome back. In this video, I'm doing a repost where I'm combining a two-part video that I did some years ago on forging your own leather punches. These punches are totally hand forged and forge welded, so I hope you enjoy the video. Today I'm going to be forging a leather punch, and if you're not familiar with this tool, it's basically a hammer-driven punch that cuts a circular hole in leather. There are basically two different designs for this type of punch. Today I'm going to be working on a relatively small punch, and next time I'll show you how to make punches for larger diameter holes or shapes. For the smaller punches, you can see here how the material has been cross-peened out and then wrapped around to form the barrel. At the top you can see where there's a gap, and that's because I didn't quite have enough material to get all the way around to form the tube. But that's okay, that isn't the working end of the tool. I was concentrating on the cutting edge, and that I believe is welded fairly well. I'm going to be forging the punch today out of a piece of crowbar, and this is basically just a 5/8 hex bar, and it's basically a spring steel. It's the equivalent of 5160. I have no idea specifically what this tool steel is, but I've always treated it like that, and it's worked fine. The first thing I'm going to do is create the offset that separates the handle from the barrel of the tool. Next, I need to start cross-peening the material until I get the width that I need to make the barrel of the punch. Now that I have the main area flattened out, I'm going to start concentrating on one side of the punch at a time. I'm going to spread one side out, move to the other side, spread that out, and then work back and forth until I get the dimensions that I'm looking for. At this point, I'm ready to start forming the barrel of the punch. There's nothing really too complicated about this process. You just have to take your time and make small changes to the bar. Once you've kinked it or hammered too much in one area, it can be quite difficult to get it back right. So it's easier to take more heats and just make sure that the shape develops gradually. Before the bar cools off totally, I apply flux to the weld area. It's not hot enough to melt it, but there is enough melted on there to prevent any scale from forming as I heat it back up. At this point, I can set it aside and I can go to work on the fire. I need to prep the fire to get it ready for welding. The first thing I like to do is take the poker and work around the fire and see what I have to work with. If I have a lot of hard packed coal, I usually break those up into lumps so that they'll burn a lot easier. After I have everything broken into lumps that I can use, I'm going to take the poker and rake through and make sure that I don't have any flickers. So now I'm ready to start raking it all back into a pile, and then I can turn it into a welding fire once again. I'm going to start with a pretty heavy air blast. I'm not worried about burning any metal because I don't have it in there yet, but I need to reestablish the fire and I need to get everything really glowing white hot. At this point, I have a white hot fire again. I go around with my ladle, make sure that everything's tight, and I'm ready to put the metal into the fire. You can tell I have a good fire here because I haven't touched the blower in the last 15 or 20 seconds, and I still have this white hot glowing mass in the center of the fire. So when I give it some air, it's really going to take off quickly. So the air blast at this point is really critical. I'm starting off with a fairly good blast because I want to reestablish that fire. The metal's cold, so I'm not worried about oxidizing the metal, but I need to get that furnace going. So I have a white hot fire. I've buried the steel. You have to have coal on top of your steel. If you can see the steel, there's a way for it to cool off and you're not going to get a welding heat. You need to bury that in the fire, have lots of coal underneath and a fair amount of coal on top. And you need to get everything white hot so it's this furnace that radiates that heat back into the steel. because once the steel starts getting hot, you need to throttle back on your air blast. So you need that concentration of heat to drive into the metal. You can't supply air to it at this point because that'll cause it to burn. And here I'm just setting the weld with some pretty light hammer blows. I'm working on both sides of the seam and just trying to mush the two surfaces together. I am doing my best to make a weld here, but in reality, I really don't need to have this welded at all. As long as the surfaces are pushed together to a point where they become seamless, this tool will work just fine. Any kind of a weld that you do achieve is really just a bonus. So here I've jumped ahead in the process. I've done all the rough grinding that I needed to do to get the cutting edge pretty much shaped, and I've hardened it. So this is an oil hardening steel, so I heated it to a red heat, which is just above critical, and I quenched it in oil. And now I'm drawing the temper, and you can see the oil starting to burn off. The temper color that I'm looking for is kind of a reddy brown. It's just before it starts turning to a purple and a blue shade. That leaves a pretty good cutting edge, but it's still pretty impact resistance. So you can do a lot of hammering with it and it'll stand up to the abuse. You can see how the color just kind of looks like a bit of surface rust on it, but that's actually the oxidation color that I was looking for. This week I'm going to be forging a larger diameter leather punch. So these punches are made out of two separate pieces. The cutting edge is a hard steel, and I'm going to be welding that to a mild steel handle. I'm going to be using an old file for the cutting edge. Files have traditionally been known as the best quality steel that was available for recycling, but nowadays, unfortunately, files are made in a lot of different ways, and you're not always dealing with a hardenable steel, so it's important to test to make sure that your steel can be heat treated. The first thing that I need to do is take a few minutes and square up this stock. Files are tapered towards the tip, so I just need to bring that taper back so I have an even thickness, so that when I wrap it around in a circle, I'll have two pieces that are the same size. Here I've cut the piece from the file, and I'm just putting another scarf on the opposite end. The length of the piece that you're working with really doesn't matter. Again, if you're making a series of these, take note of the length that you're using so you can add and subtract whatever you need to make the other sizes that you want. But just as an example, I just picked an arbitrary length that I figured would be long enough to make a decent sized circle. But as a quick estimate, the length of the piece needs to be a little more than 3 times the diameter that you want to end up with. Of course, if you're working with thicker metal, you need to factor in the thickness of the stock that you're using, but for thin stuff like this, that'll get you pretty close to a final dimension. And the setup for welding this ring is exactly the same as I do for everything else. Take your time, don't overheat the piece, let the heat soak into the metal, and take very light hammer blows to set the weld. I'm not going to worry about getting the ring too round at this point. It's going to deform quite a bit as I'm welding the handle to the cutting edge. So all the truing up is going to need to be done after the two pieces are together. Now that I'm satisfied that I have a solid weld for the ring, I'm ready to move on to the handle, and for that I'm just going to be using a piece of 1/2-inch square bar. This is just mild steel, doesn't have to be anything special. I'm going to be upsetting the end of the bar very slightly. I basically just want the end to flare out on two sides. This will give me just a little bit of extra material when I need to make the scarves later on. So I'm going to be doing a little bit of upsetting, and then I'm going to flatten one face to make sure that all the material is moving off to the sides. Here I'm dressing up a hot cut that's gotten a little too thick. I don't grind away the material here, I just reforge the end to the shape that I'm looking for. This chisel is made out of spring steel, but I don't bother heat treating it. It's working in soft metal, so the toughness of the steel is all that you really need to have a serviceable tool. So once I reforge the end, just let it cool down slowly and it's ready to go. So now I need to split the bars so it can wrap around the cylinder that I just made. The flared parts are sitting on the anvil, so they're to the left and right of this cut. Next, I'm going to use a larger stake anvil to start curving the legs around. At this point, I'm ready to start forging the scarf joints that's going to connect the handle to the cutting edge. Here's where I need that extra material that I upset earlier. The scarf needs to flare out on three sides, and if I didn't upset the material, it would probably wind up being too thin, and by the time I forge welded it to the cutting edge, there'd be hardly anything left there. So the extra material allows you to create a scarf that has a thicker cross section, and that gives you the forging time that you need to create a good solid weld between the handle and the cutting edge. And here's the part of the process that can get pretty frustrating. The handle needs to clamp on to the cutting edge while you have it in the fire and getting it ready to forge weld. So you have to play around with this until you get the fit just right. It's definitely a process that could use an extra set of hands if you have somebody available. But if not, it is, a little frustrating, but it eventually works. Once you have it held in position, you need to have your fire ready, and there needs to be a space for this to go. So use a pair of tongs or a poker or something to create a groove for this to sit in. You can't go jamming this into the fire because the ring will get knocked out of position. When all that's ready, pick it up very carefully and then just rest it inside the fire and carefully cover it with coals and get it to a welding heat. When you're ready to weld, reverse the process. Don't just pull it out of the fire. Use a poker to move the coals away from the piece and then bring it over to the anvil to tack it. Once you have one leg tacked in place, you go ahead and fine-tune the position of the cylinder and get the other side ready for welding. When I'm satisfied that I have a couple of good welds there, I can do the final shaping of the piece. I'm not going to worry too much about the finish on the outside because that'll get taken care of with all the grinding that needs to be done to this piece. At this point, I'm ready to head over to the grinder and start defining the shape of this piece. So here's the leather punch pretty much done. I've done all the grinding that I'm going to do. I've heat treated it, or at least I've hardened it. I'm getting ready to draw the temper right now, and once I've done that, I'm going to hone the final cutting edge on it. So this is pretty much the way it's going to look. I haven't cut it from the bar yet. I'm using that as a handle, so that'll be the very last thing that I do when everything is done. I'm using the frying pan once again to draw the temper, and I put a test piece in so you can see the color that I'm going after. It's kind of a reddy brown. When the test piece has stabilized to that color, I know that I can put the piece that I'm working on in there, and I can leave it in there as long as I like it. It will not go beyond this temperature. So it's a handy way to heat treat a lot of material, or heat treat an awkward piece like this where there really isn't any way to get the heat to the cutting edge that you want. So I'm just going to put it in here and just roll it around until I'm convinced that the heat has traveled through the entire piece. You'll notice that I switched out the sand and I have some brass shavings in the frying pan. They transfer the heat a lot faster than sand does, so that makes the process a lot quicker and saves a lot on gas. So at this point, all I need to do is go over to the hand grinder and put on the final edge and see how it works. Well, I got most of the way through. Obviously, there's still an edge there that's a little flat, but everything held together and nothing shattered, so I guess we're all right.